Hello everyone, welcome to Creative Civil Engineering Coach. In this video, I'll be discussing about PGCET Civil Engineering question paper from the year 2009 and I'll be providing the complete analysis and detailed solution for this question paper. So let's begin with the part 1 questions. Question number 1. Compaction factor test is used to measure. Compaction factor test is defined as the ratio of weight of partially compacted concrete to the weight of fully compacted concrete. So compaction factor test is mainly used to determine the workability of the concrete. So option C is the right answer. Question number 2. The member of truss carrying compressive stress is generally called as. So let's draw a diagram of a roof truss so that you can clearly understand the concept of roof truss. This member is called as tie beam or horizontal beam, which mainly resists tensile force, and these members are called as struts, which mainly resist compressive force or compressive stresses, and these members are called rafters or common rafters. These rafters acts as a supporting member of a roof truss, and these are the purlins which tie the common rafters and struts by stabilizing and reinforcing the rigid frames. Components are called purlins. So, the member of the truss carrying compressive stress is generally called as struts. Option A is the right answer. Question number 3. Slenderness ratio is important in the design of. Slenderness ratio is defined as the ratio of effective length of the column by least radius of gyration, and it is denoted by the symbol lambda, where least radius of gyration is given by square root of I by A, where I is the moment of inertia of the section and A is the area of the cross section. Slenderness ratio is used to find out the design load as well as in classifying the column category such as short, intermediate or long columns. And slenderness ratio is an indication of buckling failure of the column. As the slenderness ratio increases, there will be more tendency of the column to fail by buckling effect. So option B is the right answer, that is compression members. Question number 4. Purlin is in a roof truss. Purlin acts as a structural supporting member which ties the common rafters and struts of the roof truss. So it will be a horizontal member of the truss. Option A is the right answer. In a 3D view, you can clearly understand where the purlins are placed and how it looks. This is the roof truss, and you can observe here, this is the purlins which ties the common rafters and struts. So it is an horizontal member of the roof truss. Option A is the right answer. Question number 5. Cable is a structural member predominantly under. Cable acts as a structural member that can hold a great amount of tensile force with relatively a smaller cross section area. So it is called as tensile structural members. So option A is the right answer, that is tension members. Question number 6. Tar steel Fe415 possess less in comparison with mild steel Fe250. So for a Fe415 tar steel, it possesses less toughness compared to mild steel Fe250. So option D is the right answer, that is toughness. Question number 7. In a pre-stressed concrete beam, concordant profile represents for a certain set of external loads to some scale, that is influence line diagram. Option D is the right answer. It is the one which does not cause secondary stress. The minimum reinforcement in slabs if M20 and Fe250 are used. As per IS 456-2000 codal provisions, the minimum reinforcement for M20 grade concrete and Fe250 grade of steel, it will be 0.12% of gross area. Gross area. Option B is the right answer, 0.12%. Question number 9. The splicing of reinforcement in RCC columns in a framed building structure is to be done preferably at a section having. So splicing is the method used to join the reinforcement bar so that force is transferred effectively from one bar to other. and this force is first transferred to concrete through bond from one bar and transferred to other, forming splice. If the bending moment is 0, then the splicing of the reinforcement bar in RCC beam is required. Option B is the right answer, that is 0 bending moment. Question number 10. The size of the standard cubes used to assess the compressive strength of the concrete is, that is 150 mm by 150 by 150 mm. Option C is the right answer. Question number 11. Rivet value or bolt value is the strength of rivet or bolt in bearing, bending and torsion. Option B is the right answer. Question number 12. In a plate girder, the shear stress is resisted by, so as per IS 800-2007 codal provisions, for a plate girder, the maximum shear stress at neutral axis is resisted by web of the plate girder. So, the shear stress will be resisted by web plate. This will be maximum shear stress. So, option C is the right answer. Question number 13. In a leveling, height of the instrument is computed as, consider a irregular ground profile and the staff held at a known RL of the benchmark, and you are taking a staff reading at an instrument station A. So, the height of the instrument HI is given by RL of benchmark plus backside. So, the right answer is option B. Height of the instrument is given by RL of the benchmark plus backside. Question number 14. A series of closed contour lines on the map with lower values on inner side and higher values on outer side represents. Consider a contour profile So, in this contour profile, you can observe here the lower values of the contour lines is inner side and the higher value is outer side. So, this type of the contour profile represents depressions. And suppose in a contour map, if the higher value is inner side and lower value is on outer side, this type of the contour represents hill or mountains, that is hill or mountains. In the given question, they are asking for lower values on inner side and higher values on outer side represents. So, this type of the contour represents depressions. Option B is the right answer. Question number 15. Staff reading on benchmark in a leveling exercise is always taken as backside. In a leveling exercise, the first staff reading should be taken at backside. Question number 16. The instrument used for orientation of the plane table. Orientation in the plane table surveying is the process of putting the plane table into some fixed direction so that line represents a certain direction on the plan is parallel to the direction on the ground using trough compass. Option C, compass is the right answer. Question number 17. The relation between Young's modulus E and the bulk modulus K when Poisson ratio mu is equal to 0.25. From the elastic constant relation, we know that the relation between Young's modulus E is equal to 3K 1 minus 2 mu. So, by substituting the given value of the Poisson ratio, that is mu equal to 0.25, we will get E is equal to 3 by 2 K or E is equal to 1.5 K. So, option C is the right answer. Question number 18. Modulus of elasticity of a steel is. Modulus of elasticity is also called as Young's modulus and it is defined as the ratio of stress by strain and it is expressed in Newton. So, the modulus of elasticity of the mild steel is 210 GPa or 2.1 into 10 to the power of 5 Newton per mm square. Option A is the right answer. The ratio of maximum shear stress to average shear stress in a beam of a rectangular cross section is. Option B is the right answer. the ratio of maximum shear stress to average shear stress of a rectangular beam is 1.5. Question number 20. The point of counterflexure in a uniformly distributed load is a point where? Consider a uniformly distributed loaded beam of W kilonewton per meter, and this is the corresponding bending moment diagram for the beam, and this is the positive bending moment and this is the negative bending moment. Now you can observe here, this is the point of counterflexure where the bending moment changes from positive to negative. So the right answer is option C. Bending moment changes its sign. That is the point of counterflexure. Question number 21. In a cantilever beam of a rectangular section and subjected to a uniformly distributed load, the maximum bending stress occurs at neutral axis at free end. Consider a cantilever beam subjected to load, concentrated load at a free end, and this is the corresponding bending stress diagram for a cantilever beam. So the maximum bending stress in a cantilever beam occurs at neutral axis of free end. The top stress will be in tension and bottom will be in compression. Question number 22. For a rectangular element subjected to stress in a two mutually perpendicular directions on the principal plane, the shear stress is. So the shear stress will be minimum at the two mutually perpendicular directions on the principal plane. So option C is the right answer. Optimum moisture content and maximum dry density are determined for the soil sample in compaction test. Option C is the right answer. In the compaction test, the relation between the optimum moisture content and maximum dry density is given by the graph like this. For a particular optimum moisture content, we obtain the corresponding maximum dry density. Optimum moisture content is the moisture content at which the soil allows the maximum dry density. So option C is the right answer. Question number 24. Direct shear test on a pure dry sand indicates. In a pure dry sand, the cohesion will be 0 and the angle of internal friction will not be equal to 0. Option B is the right answer. Question number 25. Angle of internal friction of a soil is determined by. Angle of internal friction for a given soil is the angle on the graph of a shear stress and normal effective stress at which shear failure occurs. It is determined by direct shear test or triaxial stress test. So option C is the right answer, that is shear test. Question number 26. Contact pressure distribution beneath the rigid footing on a cohesive soil is. For a rigid footing on a cohesive soil, the pressure distribution diagram looks like this. So this is the pressure distribution below the rigid footing, and it will be maximum at edges and minimum at center. So the right answer is option B. It will be more at the edges compared to middle. Question number 27. Pycnometer is used to determine. Pycnometer is an instrument used to determine the water content of the soil and specific gravity of the soil. So option D is the right answer, that is specific gravity of the soil. Question number 28. Following type of the foundation is deep foundation. A deep foundation is also called as pile foundation, and these type of the foundations are formed by long slender columnar elements typically made from steel or RCC or sometimes timber material. A foundation is described as pile foundation when its depth is greater than 3 times of the breadth of the foundation. So option B is the right answer, that is pile foundation. Question number 29. The rate of filtration of pressure filtration is. In a water treatment units, the rate of filtration for slow sand filter is around the range of 100 to 200 liter per meter square per hour, and for a rapid sand filter it is about 3000 to 6000 liter per meter square per hour, and for a pressure filter it is about 6000 to 15000 liter per meter square per hour. The range of pressure filter, so the range of rate of filtration in the pressure filter is greater than rapid sand filter, and the rate of filtration in the rapid sand filter is greater than slow sand filter. So that is option D is the right answer. The rate of filtration of a pressure filter is greater than that of rapid sand filter. Question number 30. Acidity of sewage is indicated by a pH value of. If the pH value is less than 7, it is termed as acidic in nature, and if the pH value is greater than 7, it is alkaline in nature. So option A is the right answer. Acidity of the sewage is indicated by a pH value of less than 7. Question number 31. The pH of the fresh sewage is usually. The fresh sewage is generally alkaline in nature, and it depends upon the composition and percentage of the sewage constituents, and normally ranges from 7.5 to 9.5. So it is greater than 7. Option B is the right answer, that is more than 7. Question number 32. If the sewage contains greases and fatty oils, they are removed in. It is skimming tanks. Option D is the right answer. Skimming tanks is a chamber so arranged that the floating matter like oil, fats and greases etc. rise and remain on the surface of the wastewater, while the liquid flows out continuously under the partitions or baffles. So option D is the right answer. Question number 33. If the fluid particles move in a straight lines and all the lines are parallel to the surface, then the flow is called. This type of the fluid particles moving in straight lines and the lines are parallel to the surface is laminar flows. So in this type of the laminar flows, the fluid moves along the well-defined paths or streamlines, and all the streamlines are straight and parallel. It is also called as streamline flow or viscous flow. Question number 34. Cumulative speed distribution curve is usually adopted for geometric design of highway. The percentile speed for geometric design is, as per IRC, the geometrical design of highway, the cumulative speed distribution curve is given by the following graph, that is cumulative vehicles in percentage along y-axis and speed of the vehicles in x-axis. So the distribution curve looks like this, and these are the corresponding maximum, minimum and safe design speed. This is the minimum speed, this is the safe speed, and this is the design speed. For a design speed, it is taken as 98th percentile, and for safe speed it is taken as 85th percentile, and for minimum speed it is taken as 15th percentile. For the geometric design, the percentile speed is option A, that is 98th percentile speed. Question number 35. Bituminous pavement is a type of which pavement? So bituminous pavement is a type of flexible pavement consisting of mixture of asphaltic on bituminous material and aggregates placed on the bed of the compacted granular material of appropriate quality in layers over subgrade. So option B is the right answer. It is a type of flexible pavement. Question number 36. Super elevation becomes necessary on. Super elevation becomes necessary when a vehicle is moving in a curved path to counteract the effect of centrifugal force and to avoid skid and slip of the vehicles. Therefore, super elevation is provided by raising the outer edge over inner edge of the road. Option A is the right answer, that is horizontal curve. Question number 37. Phenomenon of water hammer is due to. Water hammer is a result of pressure surge or high pressure shock waves that propagates through a piping system when a fluid is in motion and forced to change direction or stop abruptly. So option C is the right answer, that is sudden closure of the valve. Question number 38. A dam reservoir not provided with gate controls on its spillway and other sluices is called as. It is retarding basin. Option C is the right answer. Retarding basin are the low-lying areas of land set aside to temporarily store storm water during heavy rain and reduce the flooding. So option C is the right answer. Question number 39. Crop ratio is the ratio of area irrigated. Crop ratio is the ratio of Rabi season to the Kharif season. Option A is the right answer. Question number 40. Critical depth is. Critical depth is the depth at which specific energy of a given flow rate is at minimum for a given discharge and cross-section geometry. There is only one critical depth. So option B is the right answer. That is depth corresponding to critical flow. Question number 41. Reciprocal pumps are suitable for. Reciprocal pumps are ideal for high pressure and low flow applications. It is suitable for low discharge at high heads. So option A is the right answer. Question number 42. A line joining places of equal rainfall is called. Line joining the points of equal rainfall on a map in a given period is called isoheights. So option D is the right answer. It is a form of map contour line displaying precipitation. Question number 43. A catchment is located in hilly and rugged area. The area of the catchment is about 8,000 square kilometer. The method of calculating the mean rainfall over this catchment would perfectly be. That is isoheightal method. This method is used to estimate the mean precipitation across an area by drawing lines of equal precipitation. So option C is the right answer. That is isoheightal method. Question number 44. In a gravity dam, the main restoring force is. In a gravity dam is a structure which is designed in such a way that its own weight results the external force. So option A, that is self-weight of the dam, is the main restoring force of the gravity dam. Option A is the right answer. Question number 45. Penetration test on bitumen is used to determine its. Penetration test on bitumen is done to know hardness or softness of the bitumen used in the road construction by measuring the distance in tenths of a millimeter to which a standard needle will penetrate vertically into a sample of bitumen under stipulated condition of temperature, time and loading. So it is mainly used to determine its grade. Option A is the right answer. Question number 46. The method of design of flexible pavement as recommended by IRC is. That is CBR method. Option B is the right answer. It can be used to find the pavement thickness and that of individual courses in addition to thickness of CBR values of materials of the courses. Question number 47. Flexible pavement distributes the wheel load through a set of layers to the subgrade by the grain to grain action. So option C is the right answer. Question number 48. In CBR test, surcharge weights are used to. Surcharge weights are used to stimulate the effect of overlying pavement, that is overburden pressure. So option C is the right answer. That is stimulate the effect of overlying pavement. Question number 49. Muller-Breslau principle in structural analysis is used to. So this principle is used to determine the influence line diagram. Influence line diagram for any force function is used for both statically determinate and indeterminate structures. So option A is the right answer. Question number 50. In a plate girder, the web plate is connected to flange plates by fillet welding. The size of the fillet weld is designed to resist. Consider a plate girder of I section. This is the top flange and this is bottom flange. And this is web plate of the plate girders, and these are the fillet welds which is used to weld between the flanges and web plates. The flange plates of the plate girders are designed to resist bending moment or bending stress which will be acting on the beam by developing the compressive force in one flange and tensile force in another flange. And these web plates are designed to resist the shear stress acting on it. And the fillet weld used to weld between the flanges and web blades are designed to resist the horizontal shear force at the junction of flange and web blades. So option C is the right answer. So this completes part 1 questions of this question paper. Now let's begin with part 2 questions. Question number 51. Instead of central concentrated load P, the equivalent UDL W per meter for a simply supported beam of span L such that both loadings produce the same maximum bending moment is. So for a simply supported beam of span L with the central concentrated load P, the maximum bending moment is given by PL divided by 4. And for the same simply supported beam, the central concentrated load is replaced by UDL, that is W per meter for a span length of L. Then the maximum bending moment is given by WL square by 8. For both these cases, the loading conditions is changed, therefore W is equal to P by L. So at W is equal to P by L, there will be maximum bending moment. So option A is the right answer. Question number 52. If two forces equal to P in magnitude acting at right angles to each other, then the magnitude of resultant force will be. If the third force is the resultant, it can neutralize the effect of two forces. Then the magnitude of the resultant force is given by square root of F1 square plus square root of. Then the magnitude of the resultant force is given by square root of F1 square plus F2 square. Since both the forces are equal in magnitude, that is P square plus P square, then the resultant force is equal to square root 2P. So option C is the right answer, that is root 2P. As the two forces are at right angles to each other, so the resultant force must be in the same plane of the two forces. Question number 53. In a detailing for RCC slab, if required AST is 382 mm square, then the spacing of 10 mm dia bars is. We know that for a spacing of RCC slab, AST Question number 53. In detailing for RCC slab, if required AST is 382 mm square, then the spacing of 10 mm dia bars is. For spacing calculation, we use the formula spacing S equal to AST provided by AST required. AST provided is 10 mm dia bars, so pi 10 square by 4 divided by AST required is 382 mm square. So if you calculate this, you will get the spacing as 205 mm. So option B is the right answer, 205 mm. Question number 54. If the stress sigma x is equal to 500 MPa and sigma y is equal to 500 MPa acting on a plane square element, then the normal stress on a plane inclined at 45 degree to x axis is. So the normal stress at any angle is given by the formula sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cos theta. Sigma x is equal to 500 and sigma y is equal to 500 divided by 2 plus 500 minus 500 divided by 2 multiplied by cos 2 into 45 degree. Since the angle of inclination is 45 degree. So if you calculate this, you will get the normal stress as 500 Newton per mm square. So option D is the right answer, that is 500 MPa. Question number 55. When both the ends of the column are fixed, the Euler crippling load is P. If one end of the column is made free, then the crippling load changes to. We know that The Euler crippling load general formula is given by PCR is equal to pi square EI by L square. That is, crippling load is inversely proportional to square of the effective length of the column. When both ends of column are fixed, effective length of the column is given by L by 2. When one end of the column is fixed and other is free, effective length of the column is given by 2 times of the length of the column. So, equating the both conditions of the column, that is PCR 1 into L by 2 square is equal to PCR 2 multiplied by 2L square. So, P into L square by 4 divided by P2 into 4L square. Therefore, L square will be cancelled and P2 is equal to P by 16. So option B is the right answer, that is P by 16. Question number 56. If a quadrantal bearing of a line is north 45 degree west, then the whole circle bearing is. So let's draw a quadrantal bearing system for a given line, that is north, east, west and south. So the given quadrantal bearing is north 45 degree west. So it lies in the northwest quadrant, that is in 4th quadrant. So whole circle bearing is given by 360 minus reduced bearing, that is 360 minus 45. So whole circle bearing will be 315 degree. So option A is the right answer. Question number 57. In a leveling exercise, the reading on a staff held at A is 1.6 meter and at B is 1.2 meter from same instrument station. So consider a irregular ground profile with instrument station P, which is used to measure the staff held at A is 1.6 meter and the staff held at position B is about 1.2 meter. Now you can observe here, the staff held at position B is of greater elevation than staff held at position A by a difference of 1.6 minus 1.2, that is 0.4 meter. So staff held at B is at higher elevation than staff held at A by 0.4 meter. So option A is the right answer. Question number 59. In a drained triaxial compression test, a saturated specimen of pure sand fails under a deviated stress of 3 kg per square centimeter when cell pressure is 1 kg per square centimeter. The effective angle of shear resistance is. So we have to find the effective angle of shear resistance. For a drained triaxial compression test, the minor principal stress is given by cell pressure, that is 1 kg per centimeter square, and major principal stress is equal to cell pressure plus deviator stress. So cell pressure is 1 kg per centimeter square and deviator stress is 3 kg per centimeter square. So the major principal stress will be 4 kg per centimeter square, and we know that major principal stress is equal to sigma 3 tan square alpha, that is 4 is equal to 1 into tan square alpha. Tan square alpha is equal to 4 by 1, that is alpha is equal to square root of tan inverse of 4. So alpha is equal to 8.715 degree. So the effective angle is given by alpha is equal to 45 plus pi by 2. 8.715 is equal to 45 degree plus pi by 2. So pi by 2 is equal to 36.78 degree. So the effective angle is around 37 degree. So option C is the right answer, 37 degree. T. An open channel having a rectangular shape carrying a discharge of 10 meter cube per second with a depth of flow 1.5 meter and bed slope of 1690. What will be the discharge through the channel at same depth if the slope would be 1:1000? So we have to find the discharge for the same depth and change in slope. We know that discharge is directly proportional to square root of slope. So Q1 by Q2 is equal to square root of S1 divided by S2. Q1 is 10 meter cube per second. Q2 we have to find slope for the first discharge, that is 1 in 1690 divided by slope for the second discharge we have to find, that is 1 in 1000. So 10 divided by Q2 is equal to square root of 0.5917, that is equal to Q2 10 divided by 0.7692. Q2 is equal to 13 qmx or 13 meter cube per second. So option D is the right answer, that is 13 meter. Question number 61. A body weighs 150 Newton in air and was found to be weighed on 100 Newton when fully submerged in water. The specific gravity of the body is. So to find the specific gravity, we know that specific gravity G is equal to W1 divided by W2 minus W1. This is the initial weight which is weighed on air, that is 150 Newton, and when it is found to be submerged in water, the reduced weight is 150 minus 100 Newton. So the specific gravity is given by 150 divided by 50. So specific gravity is around 3. Option D is the right answer, that is 3. Question number 62. The population of a town in 3 consecutive years are 5,000, 7,000 and 8,400 respectively. The population of the town in 4th consecutive year according to geometrical increase method is. So we have to find the 4th consecutive year population. As per geometrical increase method, to find the population of nth year, the formula is given by P0 into 1 plus R divided by 100 to the power of n, where R is the growth rate of the increasing population, that is 7,000 minus 5,000 divided by 5,000 plus 8,400 minus 7,000 divided by 7,000 divided by 2. So the increase in rate of growth of population is around 0.3, that is 30%. Population for 4th consecutive year is given by P3 1 plus 30 by 100 to the power of 1, where n is the number of decades. So P4 is equal to P3 is 8,400, 1 plus 0.3 to the power of 1. So on solving this, you will get the population for 4th consecutive year is 10920. Option D is the right answer, 10920. Question number 63. The amount of bleaching powder containing 20% of available chlorine needed to chlorinate rural water supply covering a population of 10,000 at 50 LPCD at the rate of 2 ppm is. So let's write down the given data. Population is 10,000, chlorine dosage is 2 ppm and discharge is 50 liter per capita day. So total supply is given by 50 LPCD multiplied by total population, that is 10,000, that is equal to 50 into 10 to the power of 4 liter per day, that is equal to 5 into 10 to the power of 2 meter cube per day. We know that 1 ppm is equal to 1 mg per liter is equal to 10 to the power of minus 6 kg divided by 10 to the power of minus 3 meter cube. So it is equal to 10 to the power of minus 3 kg per meter cube. Amount of chlorine required daily is equal to 2 ppm multiplied by 5 into 10 to the power of 2 meter. To convert parts per million into kg per meter cube, 2 into 10 to the power of minus 3 multiplied by 5 into 10 to the power of 2, we will get the amount of chlorine required for daily is 1 kg. Now we have to find the amount of bleaching powder for 20% of available chlorine, that is equal to 1 divided by 20 divided by 100, that is equal to 5 kg. So option B is the right answer, that is 5 kg. Question number 64. A beam of rectangular cross section with width 40 mm and height 60 mm. If this section is subjected to shear force 36,000 Newton, then the maximum shear stress at the section is, as per IS 456-2000 codal provisions, the average shear stress is given by total shear force divided by area of the cross section. That is, for a rectangular cross section, the area is B into D. So total shear force is 36,000 Newton and area is 40 into 60. So if you calculate this, you will get the average shear stress is around 15 Newton per mm square. Then maximum shear stress is given by 1.5 times of average shear stress, that is equal to 1.5 multiplied by 15, that is equal to 22.5 Newton per mm square. So option C is the right answer, that is 22.5 Newton per mm square. Question number 65. For a circular column having its end hinged, the slenderness ratio is 160. If the diameter of the column is 200 mm, then the length of the column is. So we have to find the length of the column using slenderness ratio relation. We know that slenderness ratio lambda is equal to effective length of the column divided by least radius of gyration, where least radius of gyration R minimum is equal to square root of I by A. I is the moment of inertia of a circular section, that is 5d to the power of 4 divided by 64, divided by area of the circular section is 5d square by 4. 5d square by 4. On solving this, 4 ones are 4 16s are square root of d square by 16. So R minimum will be equal to d by 4. Since the diameter of the circular column is given, R minimum will be 200 divided by 4, that is equal to 50 mm. Substituting these values in the slenderness ratio relation, that is 160 is equal to L effective divided by least radius of gyration is 50. So effective length of the column is equal to 50 into 160, that is equal to 8000 mm. So effective length of the column will be 8 meter. Option A is the right answer. Question number 66. For a beam of rectangular cross section, if the depth is doubled, then the deflection decreases by a factor. Deflection is inversely proportional to moment of inertia of the cross section. For a rectangular beam, moment of inertia is given by Vd cube by 12. So deflection factor is found by depth ratio, that is d cube divided by 2d cube. that is equal to d cube divided by 8 d cube. D cube will be cancelled. Depth ratio will be 1 by 8. So the reduction factor is equal to 1 divided by depth ratio. So reduction factor is 8. Option B is the right answer. Question number 67. The laced column is designed to carry 500 kN axial load. Then the total shear resisted by a lacing system is. The total shear resisted by lacing system is equal to 2.5% of axial load. That is equal to 2.5 divided by 100 multiplied by 500 is the total axial load. So you will get the total shear resisted by lacing system is around 12.5 kN. So option C is the right answer. Question number 68. The deflection of flow line at the intersection of two dissimilar soils having the coefficient of permeability K1 and K2 occurs as the flow line makes angles θ1 is equal to 60 degree and θ2 is equal to 30 degree to the interface before and after the intersection. Then we have to find the relation between the two permeability coefficients, that is K1 and K2. According to law of deflection of flow lines at interface of dissimilar soils, we know that tan θ1 by tan θ2 is equal to K1 divided by K2. That is tan 60 degree divided by tan 30 degree is equal to K1 divided by K2. If you solve this, tan 60 degree divided by tan 30, you will get 3, that is equal to K1 divided by K2. So K1 is equal to 3 times of K2. So this is the relation between two permeability coefficients. So option D is the right answer. Ka is equal to 3ab. Question number 69. The Thiessen weights for 4 rain gauges A, B, C and D covering a river basin are 0.15, 0.25, 0.30. Question number 69. The Thiessen weights for 4 rain gauges A, B, C and D covering a rain basin are 0.15, 0.25, 0.3 and 0.3 respectively. If the average depth of rainfall for the basin is 5 cm and the rainfall recorded at a station B, C, D are 5 cm, 4 cm and 5 cm respectively, then the rainfall at A will be. So we have to find the respective rainfall for the station A. Precipitation formula: P average is given by P1 A1 plus P2 A2 plus P3 A3 plus P4 A4 divided by A1 plus A2 plus A3 plus A4, that is equal to the average depth of the rainfall for the basin is 5 cm, that is P average is 5 cm. P1 we have to find, and area of the first rain gauge station is 0.15 plus P2 is 5 cm, 5 into 0.25 plus 4 into 0.3 plus 5 into 0.3 divided by A1 is 0.15, A2 is 0.25, A3 is 0.3, A4 is 0.3. So 5 is equal to 0.15 into P1 plus 3.95 divided by 1. Question number 70. The 4-hour unit hydrograph of a basin can be approximated as a triangle with a base period of 48 hours and a peak coordinate of 200 m3 per second. Then the area of the basin is. For the given unit hydrograph of the basin approximated as a triangle, the relation is of QT is equal to A into 1 by 100. That is, area of the given basin is equal to 200 multiplied by 48 hours 60 minutes 60 seconds multiplied by 100 divided by 2 into 10 to the power of 6. Therefore, area of the given basin for the given unit hydrograph is 1728 kilometer square. So option A is the right answer. Question number 71. Loose uniform sand with rounded grains has effective grain size of 0.03 centimeter. The coefficient of permeability. According to Allen-Azen equation, the coefficient of permeability K is equal to C into D10 square, where D10 is the effective grain size of the sand particle. Therefore, coefficient of permeability is equal to C is the constant for the calculation of the permeability, that is 100 multiplied by D10 is the effective grain size, that is 0.03 centimeter. So coefficient of permeability is 0.09 centimeter per second. So option B is the right answer, 0.09 centimeter per second. Question number 72. The radius of horizontal curve is 100 meters. If the design speed is Question number 72. The radius of horizontal curve is 100 meters. The design speed is 50 kmph and the design coefficient of lateral friction is 0.15. What would be the rate of super elevation if full lateral friction is considered? So we have to find the rate of super elevation providing the full lateral friction. According to IRC, to find the rate of super elevation, we know that the formula E plus F is equal to V square by 127R. E is the rate of super elevation to be found. F is the coefficient of lateral friction, that is 0.15. V is the design speed, that is 50 kmph. So 50 square 127 multiplied by R. R is the radius of horizontal curve, that is 100 meter. So on solving this, you will get the rate of super elevation 0.0468, that is equal to 1 in 21.20. So option A is the right answer. Question number 73. The safe stopping side distance for a design speed of 50 kmph two-way traffic on a two-lane road, assuming coefficient of friction as 0.37 and the reaction time as 2.5 seconds. So let's write down the given data. The design speed of the vehicle is 50 kmph. We have to convert this design speed given in kmph to meter per second. So 50 into 5 by 18, that is equal to 13.9 meter per second. T is the reaction time, that is 2.5 second, and F is the coefficient of friction, that is 0.37. According to IRC, the safe stopping side distance is given by the formula Vt plus V square by 2gF, that is equal to 13.9 multiplied by 2.5 plus 13.9 square divided by 2 into 9.81 acceleration due to gravity. F is the coefficient of friction, that is 0.37. So safe stopping side distance is 61.36 meter. So option B is the right answer, that is 61.4. Question number 74. A circular curve of radius 200 meter and the coefficient of lateral friction of 0.15. The design speed is 40 kmph. The equilibrium super elevation for equal pressure on inner and outer wheel would be. So we have to find the equilibrium super elevation. Equilibrium super elevation is the super elevation which, when provided, imposes equal pressure on both outside and inside wheels of the vehicle. So there will be no lateral friction of the vehicle. So F will be equal to 0. So as per IRC, to find the equilibrium super elevation, we know that the formula V square by 127R. So V is the design speed of the vehicle, that is 40 kmph. 127 multiplied by R is the radius of the curve, that is 200 meter. So the equilibrium super elevation is 0.0629, that is 6.3%. So option C is the right answer, 6.3%. Question number 75. In a design of lacing system for a built-up steel column, the maximum allowable slenderness ratio of the lacing bar as per IS 800-2007 codal provisions, the slenderness ratio for the compression member shall not exceed 145. So the maximum slenderness ratio is 145. Option B is the right answer. So this completes the part 2 questions of this question paper. I hope all the information and the solutions provided for this question paper is satisfied for your preparation of PGCET and other civil engineering competitive recruitment exams. So thanks for watching this video.